All right. So my name is Julian, and I'm going to do an introduction to Google Cloud Provider. This is going to be an audiobook for anyone who's interested, and I'm going to do this in about 9 chapters. Go through the GUI, and then eventually I'll try and make an addendum to how you can use Terraform with this. I'll try and do some stuff on the CLI, that's the command line interface. So this will be unedited. You might hear me cough, you might hear me sneeze, you might hear me open up a can of soda, but I'll try and make this as brief as possible and as comprehensive as possible. So let's go. Welcome to this foundational segment in your journey toward earning the Google Cloud Professional Cloud Architect certification. With the chapters before and after our blueprints for your architecture, this will be your toolbox. As an aspiring cloud architect, your value doesn't have to come from just knowing what GCP offers, but from understanding how to operationalize it. That's where GCP's administration tools, deployment services, and automation capabilities step in. These aren't side topics. They're essential competencies that form the real-world fabric of designing, deploying, scaling, and securing GCP environments at an enterprise level. Throughout this guide, we'll explore Deployment Manager, which is the infrastructure as code using YAML templates to automate multi-resource deployments, GCP Marketplace, a rapid application deployment using pre-built software images, Cloud SDK, a developer's command line ally for working with GCP resources using gcloud, bq, and gsutil commands. We use cloud APIs, the programmable surface for interacting with every GCP service, which securely and scalably adjusts your environment. And Cloud Shell, a browser-based terminal that gives you instant admin level access to your GCP environment. For the PCA exam, you won't just be quizzed on what these tools are. You'll be expected to know when and how to use them. For example, when do you choose Deployment Manager versus Terraform? How do you troubleshoot access with Cloud APIs? What does gcloud do that Console doesn't? How do you architect a deployment workflow using Marketplace or Cloud Shell? In a real client environment, these tools are the gears that turn your plans into production. And for the exam, understanding that architecture, benefits, limitations, and integration points will elevate your answers from competent to certified. So let's sharpen our tools and get to work. All right, chapter 1. All right, chapter 1. Welcome to the first chapter of our journey through the world of cloud computing, specifically Google Cloud Platform or GCP. Whether you're just stepping into the cloud or brushing up on your knowledge, this chapter will give you a strong foundation. I'm going to make a little mark. Okay, let's begin understanding the why behind the cloud. Pay as you go, cloud without limits. Okay, we'll go here. I'll show you pricing. All right. Okay, therefore, there are three major service models in the cloud. Infrastructure as a service, IaaS. This lets you run out computing infrastructure. Think virtual machines, networks, and storage, all provisioned on demand. Platform as a service. This provides a full deployment and development environment. You can focus on your code while the platform handles the rest. And software as a service. This delivers software over the internet. Applications like Gmail or Google Docs fall into this category. These models let you choose your level of control from hands-on infrastructure to fully managed software. Okay. Go to the overview. Show you this. I don't need to see dark mode. All right, this is a little bit of FinOps. So core services. All right. Every cloud journey begins with 4 basic building blocks. Compute. All right. Compute. All right. Compute, storage, networking, and big data. And GCP goes beyond that with identity and access management, security tools, data transfer solutions, and machine learning services. Let's break down each one, starting with compute. All right. So now that we've introduced the cloud's core models and backbone of services, let's go into compute, which is one of the most foundational pillars of GCP. When we talk about compute, we're referring to the actual processing power behind applications, the engines that run websites, data pipelines, APIs, machine learning workloads, and more. Google Cloud offers a spectrum of compute services tailored to different workload types, development styles, and operational needs. These 4 tools are especially critical, and each plays a unique role depending on your architecture goals and how much control you want over the infrastructure. So compute engine, all right? What are these? And these are my environments within this. You'll see. So think of a compute engine as Google Cloud's raw horsepower. It's infrastructure as a service. This is a platform that lets you spin up fully customizable virtual machines. Think about it as a small laptop or desktop. It's powerful as you need it to be, right? The weakest Linux box to the most powerful NVIDIA box that you can think of, right? But these are all virtual. With Compute Engine, you can select your operating system, like I said, like Linux, Mac, Windows. You can select the number of virtual CPUs, the memory size, the boot disk type, GPUs, and more, right? This is ideal for legacy applications that need full OS control, custom workloads like high performance computing or batch jobs, migrating on-premise applications to the cloud. So here's an exam tip. You're responsible for managing everything here: OS patching, networking, scaling, and uptime, and making it a good fit for complex or regulated environments. You can choose standard, high instance, or high memory, high CPU. Let's see, let's start this. Compute API, let's enable this. Okay. Yeah, for a budget sensitive task, you can do preemptible instances, which offer a cheaper, short-lived compute option. I believe it's no more than 24 hours. Compute Engine also supports instance groups, so you can have multiple. Auto scaling, you could scale from more than one to as many as you need for the workload. And then let's try this API. Okay. No, where's this going here? Let's go here. And you can create a managed set of identical instances that can automatically scale based on workload or schedule. All right. And I thought, you know what, I'm gonna go to an older project and go from there. Kubernetes. And Compute Engine. All right. You'll see the instance types. Well, let's stick with this overview, right? You'll see service health. You can see the service health, so you can start to see what the CPU, the memory, the workload, how many instances, your total VMs, your instance groups, your snapshots. I have nothing running now. Your image types and numbers and the reservations, right? And you can see how much this is going to cost you on this date right here in this window. And you can see insights offered here. All right. Let's go to App Engine. Okay. All right. App Engine. All right, so App Engine is Google's platform as a service offering. It abstracts away infrastructure, letting you focus purely on code. So within this, you can upload your application. An App Engine will handle scaling, load balancing, security patching, monitoring, health checks, and it comes in two environments, all right? Standard and flexible. Okay, let's see. Let's get started. You can select the region, select the service account. Use that one. All right. Standard would be a sandboxed runtime with instant scaling and lower costs. The flexible would be a Docker powered with more control over language versions and packages. Languages supported out of the box include Python, Java, Go, Node.js, PHP, and Ruby. If your app runs in a Docker container, it can run an App Engine flexible. This is ideal for web applications, APIs, and backend services. So here's an insight. App Engine is especially powerful when paired with services like Cloud Tasks, Cloud Scheduler, and Firestore for serverless microservice patterns. All right. So here's the languages set, like I said, standard versus flexible. And from here, you can get the Cloud SDK, which I believe I already have. And you can also do this on when you're in your local machine. So if you opened up your VS Code or whatever you use to access your Google Cloud environment. All right. So let's go to Kubernetes Engine. Let's do that. Kubernetes Engine. Kubernetes Engine, GKE, Google Kubernetes Engine, is a go-to choice for teams embracing containers and microservices. GKE is a fully managed Kubernetes service, meaning Google sets up, manages, and maintains the master nodes, which is the control plane, for you. This includes upgrades and security patches. All right. What you get, cluster-based infrastructure, built-in logging and monitoring via cloud operations, which is formerly known as Stackdriver, native auto scaling, private clusters and hardened nodes, workload identity integrations, so Kubernetes and IAM. Use cases would include CI/CD driven deployments, multi-service web backends, machine learning and data pipelines and containers. Right? Within this, you set up a cluster. All right. And so this cluster can run those previously mentioned applications that would be in containers. Within that, you could scale up to have it running as scaled up as you need on the workload or on the pods within this. So within this, you could have an application like a web application, let's say Google Maps, for instance, and then have that run throughout your entire world or wherever you would have this network to be available, right? Whatever region, whatever availability zone, that would be free for this application. All right. So important for your certification, remember that GKE, the Kubernetes Engine, is a critical component of hybrid and multi-cloud architecture. And this is important for the PCA exam. GKE also integrates Anthos, which is Google's hybrid and multi-cloud platform, and supports services like Service Mesh via Istio. All right. And within this, you'll see the workloads. Once you create a deployment that works with that application, teams, I believe the teams, yes, this lets you isolate this for your team so that you can have an enterprise style solution. Okay. And then with this, you can have fleets of Kubernetes clusters and optimize this. Right. And then you can see what your application is going to look like within here for the containers, services, and configuration that are managed. And then you can go here for your, well, AI and ML. I haven't touched that, and that will be important, but I don't think it's necessarily important for the exam. But your secrets and config map, this is going to be how you can handle your application secrets, whether that be any identity information that you need for the application or for your infrastructure to go and launch securely, right? Because you don't want to have anything hard coded, but you do want your environment and your tools to be able to run efficiently and effectively. All right. And then from here, you have your storage, which most of this is ephemeral, but you can set up persistent volumes in order to have your containers be able to run effectively and to be able to use what they need to. And on the right here, you'll see recommended tutorials within Google Cloud that go into the storage, the volumes, persistence based off of this storage section. All right. Cloud functions is going to be our next piece. Okay. This is going to be event-driven serverless architecture. Okay. Cloud functions. This is serverless and event-driven. If you're writing small bits of logic to respond to events, think triggers, hooks, or micro backend services, Cloud Functions is your tool. Cloud Functions lets you write the code to respond to a specific event in GCP and runs it on demand in a fully managed serverless environment. So you don't necessarily need those compute engines. With this, you can still accomplish that workload that you would need. And you can trigger this from cloud storage upload, PubSub messages, Firestorm or real-time database changes, or HTTPS requests. But the big thing that people love about this service is that you only pay while the function is executing. That means no idle costs, no scaling headaches. Cloud functions are stateless. They're auto-scaling. They integrate with IAM for secure access control, and they're ideal for lightweight REST APIs, automation scripts, and real-time data transformation. Languages supported include Node.js, Python, Go, Java, and more. An architecture consideration, cloud functions are perfect for decoupled microservices and event-driven pipelines, especially when used with PubSub, and workflows. So you need to always choose between the right compute options. Here's a simple breakdown for you to remember. For Compute Engine, you have a high level of control. It's best for custom VMs, migrations, and legacy workloads. For App Engine, this is a medium level of control. Web applications are optimal, APIs, and minimal operations, right? For Kubernetes Engine, you have medium to medium high level of control. This is optimal for containers, microservices, and CI/CD pipelines. And Cloud Functions, you have actually a lower level of control. You do get to initialize it, but it's optimized for event-driven logic, automation, and light APIs. Okay. For cloud digital leaders, know when to use which compute option based on business goals and operational needs. For professional cloud architects, be prepared to design architectures that use multiple compute tools together and explain the trade-offs related to cost, complexity, and scaling. These four services, compute engine, app engine, Kubernetes engine, and cloud functions, form the foundation of nearly every workload you'll deploy in GCP. Understanding how to mix and match them, when to use them, and how they interconnect is key to building resilient, efficient, and modern cloud architectures. Next up, we'll explore storage services. This will be everything that you can think of regarding storage. Until then, keep your apps running and your architecture smart. Okay. All right. Cloud storage, object storage for any use case. Cloud storage is Google Cloud's fully managed object storage solution, and it's perfect for storing unstructured data like images, videos, archives, backups, and large data set. Think of it as a scalable, durable bucket that you can access via RESTful APIs, the CLI, or CDKs. Okay. Storage classes for optimization are registered for class and utility. Okay. The four major ones include standard. This is for hot data accessed frequently. Nearline. This is for data that's accessed around once a month. Cold line. This is for long-term, infrequently accessed backups. Archive for regulatory or audit purposes with long-term retention. These all integrate seamlessly within Cloud CDN, that's the content delivery network, PubSub, BigQuery, and Dataflow. Geo-redundant with multi-regional storage for global applications. So object storage, like cloud storage, ideal for static website hosting, machine learning data sets, or storing logs and analytical outputs. Okay. And we can go through here a little bit where you can create this bucket. Use a unique name, global. All right. So and then you can usually add a date. Boom. Set this. Where? Regional, multi-region. How? Auto class, default. Here's the standard, nearline, cold line, archive. And then hierarchical name spacing. This is helping for labeling, faster folder listing. How to access this. Uniform, fine-grained. All right. And then you can continue, and then you could use your retention methods. All right. Okay. Cloud SQL. This is GCP's fully managed relational database for MySQL, PostgreSQL, and SQL Server. This fully handles backups, failover, patching, and replication. This is easy migration using Database Migration Service, DMS, and supports private IP networking, IAM database authentication, and SSL TLS encryption. And this can scale vertically and horizontally. So what does that mean? Your database can be migrated from an on-prem system or another cloud system. Any type of security issues can be patched. If you need this to be replicated, let's say you have a three-tiered architecture that needs a database for intaking orders, managing your products, and then managing your deliveries. That would be one way that you would have multiple databases, but then you could have multiple instances of those databases in order for them to not back up if there were a glut of orders. And you can migrate this, like I said, from on-prem or from another cloud, very simply using schemas. Then you could support private IP networking, so you don't necessarily have to have this exposed to the public internet. It would only interact with your other resources on GCP. IAM, that database allows you to have a password that is not just the default admin/admin. So the username and password being admin, that's not going to be useful because anyone would crack that. You can use IAM database to update the username password, limit the scope of what people can do, read only, editor, owner. And then SSL TLS encryption means that anything that goes into that database can be encrypted so that any information that goes in there, if it gets stolen, will not be available to someone to crack open. They would have to have very skilled cryptographic tools. And scaling vertically means you can have more CPU, more RAM, so that more can be processed and your CPU or RAM, which means all of that intake will not back up. And you can scale out with more read replicas so that if you do have a glut, you can have one version of that database, one instance of that database taking in all the data, and then the read replicas being able to be read by any other resources you have in your system. This is best for traditional web applications, CRM systems, content management platforms, and enterprise-grade OLTP workloads. Please note, for latency-sensitive regional workloads, to be compliant, Cloud SQL is a go-to choice. This is the database admin's go-to choice for anything GCP that is relational databases. All right. Now let's go for Cloud Bigtable. This is a NoSQL database. Okay. Cloud Bigtable. This is going to be your NoSQL for massive throughput. So if you need a horizontally scalable, low latency NoSQL database that can handle petabytes of data and billions of read writes per second, Cloud Bigtable is the answer. So that means, okay, let's go here. A terabyte, if you multiply it by 1,000, that's 1 petabyte. So you're going to have thousands and thousands of terabytes. And most people's computers at their home usually have 1 to 50 terabytes. So it's a volume of data. This is ideal for time series data, Internet of Things telemetry, user analytics. So think your weather devices, anything that comes from massive amounts of vehicles. This offers single-digit millisecond latency. So that means this is near real-time data that can stream in. The schema design resembles HBase, which is a traditional no-schema, NoSQL database, and it integrates with Apache Beam, Dataflow, BigQuery, and TensorFlow. So these are all tools that work within the Google and other server architectures so that you can have big data working through your servers effectively, and you can use them to scan and to operate other resources. So here's a tip. Design your rows carefully. Be careful to avoid hotspots. All right. And in GCP, for the exam, remember, real-time analytics is going to be key. Sensor networks, monitoring platforms, financial tick data. So think about weather machines, think about your Internet of Things devices, think about the stock market, NASDAQ, those type of real-time data needs that have to take huge amounts of data in. That would be what this would be optimized for. All right. Cloud Spanner. We're going to go to Cloud Spanner. All right. All right. Cloud Spanner. We're not going to start this up, but I'll give you a brief overview. This is one of Google's flagship database innovations. It's the world's first horizontally scalable, strongly consistent relational databases. It's globally distributed as SQL. So it supports SQL, joins, transactions, and it's global replication with the 5 nines availability. What is the 5 nines? That's 99.999% global replication. That means it's almost perfect. And it's built on Google's TrueTime system for external consistency. It's automatically sharded and replicated, which means that you'll have multiple instances so that one will not go down, and you'll have multiple availability to be able to have all this information come out, go into this database, and be able to be reassembled and be consistent. And then let's make sure you understand ACID. ACID, that should be defined. ACID. This is an acronym that refers to the set of 4 key properties that define a transaction: atomicity, consistency, isolation, durability. So what is ACID? Now this is key. All right. Atomicity. This means the entire transaction takes place all at once or doesn't happen at all. Consistency. The database must be consistent before and after the transaction. Isolation. Multiple transactions occur independently without interference. Durability. The changes of successful transactions occur even if the system failure occurs. So remember that. Okay. Okay. So this is ideal for fintech apps, SaaS platforms, global e-commerce systems. So use this when you need relational capabilities and scale beyond traditional RDBMS limits. That's for relational database management limits. All right. This is going to be global. We'll do cloud data store. Right. Okay. So cloud data store. This is a NoSQL document database optimized for serverless applications. It's schemaless, so it's a JSON-like document structure. There's built-in sharding, replication, and indexing. It supports ACID transactions at the entity group level, and it has tight integration with your app engine. This is now part of Firestore. Datastore is ideal for mobile web applications that require offline sync, low latency reads, and real-time updates. Okay. So the overview here shows that it's a highly scalable NoSQL database for your applications. It automatically handles sharding and replication, providing you high availability, durable database that scales automatically to handle your applications, right? You can see the pricing, support. Key features include multiple access methods, so JSON API, open source, or community main ORMs. All right. Has a rich admin dashboard. It's fully managed, which means Google automatically handles the sharding and replication to provide you with a high availability and consistent database. And it supports diverse data types, including integers, floating point numbers, strings, dates, and binary data. And it's ACID transaction, which is very important for any database system. All right. And then I think the next piece, hold on. Assistant. There's only documentation on it, but we'll review what persistent disks, right? So block storage for compute. When you launch your VMs with Compute Engine or containers in GKE, you often use persistent disks for data storage. These are storage blocks that will attach and detach from VMs dynamically. They'll resize without downtime. They'll be backed up by durable, replicated infrastructure. There's different types. There's standard, which are cost-effective, good for backups or batch jobs. There's SSD, which is low latency, high IOPS. So that's that interaction, the data moving back and forth. And for databases and transactional apps, there's balanced, which are going for cost and performance compromise. So when you use regional persistent disks, these will be for VM failover across zones. That would be an optimal use. So for recap, cloud storage is an object type. It's best for files, backups, machine learning datasets, and logs. Cloud SQL is a relational type. It's good for web apps, enterprise level, CRMs, and OLTP. Bigtable is good for NoSQL and good for analytics, sensor data, real-time dashboards. Cloud Spanner is a global relational database, perfect for multi-regional SQL workloads with high consistency. Cloud Data Store is a NoSQL document, which is good for App Engine apps, real-time apps, and mobile backends. Persistent disks are the block type. These are good for VM boot disks, databases, and Kubernetes volumes. With this, your data foundation in GCP will be solid. Each storage is designed with a specific trade-off in mind: performance, consistency, availability, and cost. Next, we'll move on to the thing that makes everything in GCP work: networking. Okay. Welcome to the next key pillar of Google Cloud, networking. Now that we've explored compute and storage, it's time to talk about what ties everything together: how your resources communicate, scale, and stay resilient across the globe. In the cloud, networking isn't just a technical layer, it's the invisible fabric that determines your application's availability, speed, and security. And in Google Cloud Platform, networking is a first-class citizen, engineered with global scale, software-defined control, and built-in security from the ground up. This explores GCP's essential networking services, each of which play a role in architecting reliable, high performance, and secure systems. Your VPC. This is your private network in the cloud. At the heart of GCP networking is the VPC, or the Virtual Private Cloud. Think of a VPC as your own private data center in the cloud. It's a logically isolated section of Google's network where you can define IP ranges, create subnets, and connect your compute, storage, and database services securely. Each VPC spans all regions globally, so your network is flexible by default, supports regional subnets, allowing you to place resources closer to the users, can connect to other VPCs via VPC peering, shared VPC, or VPN. And with custom rules, custom routes, firewall rules, and private Google access, you get fine-grained control over how traffic flows within and outside your network, ideal for both public-facing applications and internal enterprise systems. For the exam, know the difference between auto mode and custom mode, right? Custom mode gives you full control over subnet IP ranges and is preferred in production. You'll see this here when you can create this. There's your subnets. You can lift those. Description, your regions where you can do this, your IPs, and where is this? Um, oh, there it is. Subnet would be custom or auto, right? And here's what you say. This supports IPv single stack, IPv, or an IPv6. IPv6 is not going to be relevant quite yet, but you should understand it adds more addresses to the already 2.5 billion that are available. Okay. Okay. Cloud load balancing. This is the traffic distribution made simple. When your application scales, your network must keep up. That's where cloud load balancing comes in. Google's load balancer is a software-defined, fully managed, and global. This is capable of distributing traffic across regions, zones, and instances with zero downtime. There are different types for different traffic. HTTPS load balancer routes web-based traffic on URLs, host names, or content. There's TCP SSL proxy load balancers, which are ideal for non-HTTP traffic like game servers or messaging apps. And there's internal load balancers. These are used for routing traffic inside a private VPC. For example, across backend microservices. Remember that Kubernetes cluster we were talking about earlier? All types support auto healing, auto scaling, and health checks, ensuring that only healthy instances receive traffic. So for the exam, remember that load balancing in GCP can be regional or global. Only the HTTPS global load balancer supports cross-regional failover. This is a key point for designing high availability architecture. All right, Cloud CDN. Delivering content at the speed of light is the expectation. So users today expect instant response times, whether they're watching a video, loading a website, or downloading a report. Cloud CDN, or Content Delivery Network, brings your static content closer to users by caching it at Google's global edge locations. This reduces latency and minimizes load on your backend systems. It integrates seamlessly with the HTTPS load balancer and supports automatic caching, meaning storage at the endpoint, custom cache and validation, which, let me make sure we get this. Defining specific rules and mechanisms to remove or update cache database items. So that means nothing old will be there. Only the things that need to be there will be there. Logging and analytics, so it'll know what is going on with items in your content delivery. And SSL TLS encryption by default, meaning any data that is cached is going to be encrypted. Whether it's images, scripts, or API responses, Cloud CDN ensures that content is fast, reliable, and protected. A real-world example would include serving static assets like images, fonts, or JavaScript for a global web app. When you enable Google Cloud CDN with one checkbox, no servers will be required. All right. Set the backend bucket. Set the new The origin, define it. You could use an existing backend bucket. I hope I don't have one available. And then set this here, set the paths and rules, and then set the performance metrics. Okay. Cloud interconnect. This is high-speed hybrid connectivity. While cloud is powerful, many enterprises still run critical systems on premises. Cloud interconnect lets you link your data center directly to Google's backbone network, bypassing the public internet for better security, latency, and reliability. So it connects your on-premises to your cloud. And there are two different types. Dedicated interconnect, where you get a physical connection to Google with bandwidth with options up to 80 gigabytes per second, and partner interconnect. And this works with a service provider if you can't co-locate with a direct Google connection. Cloud interconnect supports hybrid cloud, data replication, and multi-cloud use cases with predictable high throughput links. So your on-premises data center now connects with Google directly, so you can have your on-prem workloads in the cloud. Within the certification, remember that interconnect versus VPN is a common comparison. VPNs are encrypted tunnels over the internet. Interconnect is a physical private connection. Using interconnect, you use interconnect when performance and availability matter most. Cloud DNS. This is managed DNS at scale. Every digital experience begins with a domain name. Cloud DNS is Google's scalable, reliable domain name system service, and it's designed for low latency and high availability. Supports Anycast routing for global performance, zone management for API or the user interface, private zones for internal name resolution within your VPC, and DNS security for domain security. So Cloud DNS is production ready for enterprise workloads and integrates with tools like Terraform, the Cloud CLI, and CI/CD pipelines. Basically, you use Cloud DNS for managing both public domains, right? Like these domains like console.cloud.google, maybe, or google.com, and internal service discovery across microservices and hybrid networks. So these naming conventions are very important to make sure your resources work correctly where they need to work. So to recap this, why GCP networking matters. Whether you're building a global SaaS app or deploying internal enterprise tools, GCP's networking stack empowers you to build secure, isolated environments like VPCs, scale globally and balance user traffic like cloud load balancing, serve content with low latency like Cloud CDN, connect on-premises infrastructure like Cloud Interconnect, resolve names with reliability like Cloud DNS. Combined, these services form the nervous system of your cloud architecture. They allow you to design systems that are fast, fault-tolerant, scalable, and secure by default. Everything you need to pass the exam and build production-ready systems is in this for the real world. Next up, we'll go into big data and analytics. As we continue our journey through the foundational services of Google Cloud Platform, we arrive at one of GCP's crown jewels, big data and analytics. In today's world, data is more than just a byproduct, it's a strategic asset. Whether you're building an AI model, powering a recommendation engine, analyzing real-time sensor streams, or just trying to answer what happened yesterday, you need tools that can handle data at scale. Okay. Your biggest things Google Cloud offers include a robust and interconnected suite of analytics tools meant to ingest, transform, process, store, analyze, and visualize massive data sets, all while staying performant, secure, and cost effective. So let's break down these services, the engines behind them, and why they are data-driven innovations. Okay. First up, we'll go for let's go in. Okay, go for BigQuery first. Um, okay, all right. Oops, okay, first up, we have BigQuery. This is GCP's flagship analytics product. BigQuery is a serverless data warehouse built for high performance SQL queries on petabyte scale datasets. You can load data from the cloud storage team, stream it from PubSub, or connect live to data in external services like Google Sheets. And it's fast, really fast. It uses Dremel, which is Google's columnar storage and query engine. Queries are automatically parallelized across thousands of nodes. Billing is based on the amount of data processed, not storage or compute runtime. BigQuery also supports partitioned and clustered tables for performance tuning and native integrations with machine learning via BigQuery ML and geospatial analysis with BigQuery GIS. For the exam, note that BigQuery separates storage and compute and supports both on-demand and flat rate pricing. Be sure to know how to use table partitioning and cost estimation tools. All right. And let's see. It's governance. Let's see. Hmm. You can see the recommendations here. You can see the data transfer. Since nothing's here, you see the data forms. So these are team repositories to manage code. And since we don't have anything here, we could add something, but we don't have anything in here for our data pipelines. But you can play around in this and get an idea of what is working. Okay, next up, we'll go to data proc. Okay. So sometimes you need your traditional open source data tools like Apache Spark, Hadoop, Hive, or Pig. Cloud Dataproc brings these to Google Cloud. These are managed cluster services. So with these, you get full control over the software stack, but without the operational headaches. With this, Cloud starts 90 seconds, and it's integrated into Google Cloud's BigQuery and Stackdriver. And it's pay per use. You can shut down clusters automatically when they're idle. Dataproc is ideal when you're migrating from on-prem Hadoop or want compatibility with existing tools. Unlike Dataflow, Dataproc gives you more control, but also more responsibility. It's better for teams familiar with the Hadoop ecosystem. So this is not a beginner tool. So this is fully managed, highly scalable for running Apache Hadoop, Spark, Flink, Presto, and 30 different open source tools and frameworks. So it's good for data lakes, ETL, secure data science, and at scale integrates with Google Cloud. Okay. Hmm. Hmm. Okay. Well, this isn't quite here. Okay, so Google Cloud, Data Lab, and Data Prep. These are exploring and cleaning at scale. All right. So this has some information on this. You'll have to go here, the Google Cloud Skills Boost. Raw data isn't always pretty. Sometimes you need to explore, clean, and transform data before it's ready for production. That's where these tools come in. That's Cloud Data Lab. Let me see if I can find it more specifically. Hmm. Mm, no, it's not going to be here. So Cloud Data Lab is a Jupyter-based notebook service for exploring data interactively with Python, SQL, and charts. It's great for early stage analysis and prototyping. Cloud Data Prep is a no-code tool for visually cleaning and transforming data. It's built on Trifacta. Data Prep lets you automate repetitive prep tasks, profile datasets, and export clean data to BigQuery or cloud storage. You use these when you need to understand your data before your code does. This is basically your ETL cleanup tools. All right. PubSub. All right. So Cloud PubSub, this is an API for modern architecture. We talked about this earlier. This is especially important for event-driven microservices and real-time data pipelines. With this, Cloud PubSub is critical. It's a global messaging service that decouples senders and receivers. Publishers send messages to a topic. Subscribers consume them asynchronously. This has durable storage, exactly once delivery, and message replay come built in. PubSub is ideal for Internet of Things device telemetry, user activity tracking, log aggregation pipelines, cloud functions, or data flow triggers. You need to know how this works with data flow, with cloud functions, and GKE, and how push-pull subscriptions work. So with this, you have these libraries that work and they discover your information and are able to publish it or subscribe to it in order to get an activity to happen. All right. And you can see subscription properties, topic properties. Here you go. Your queue values for how much the retention is. So if that message is missed, it will deliver eventually. We call those dead letter queues in AWS, but that's a little bit different here. But there's a number of delivery attempts. The default value is 5 attempts. The maximum value is 100 attempts. So eventually that will deliver. And you can set your retry value with your policies. And you can have it have exponential, or you can set it to retry after exponential backoff delay. That way it doesn't hit a ceiling limit. Or you can have it retry eliminate immediately in order to get the message going if there is no gap. Let's see if this is available here. Let's see genomics. This is a life cycles. Okay. So Google Genomics. This accelerates health researches. For life sciences and research teams, Google offers Google Genomics, a specialized service for storing, querying, and analyzing genomic data at scale. It's used by research hospitals, biotech firms, and pharmaceutical companies to align sequencing data, run variant calling pipelines, and share data sets across collaborators. It integrates with BigQuery for analysis and with cloud storage for effective retention. Real-world impact includes genomics helping power precision medicine, pandemic response, and global collaborative health research. Oh, looks like I probably don't have access to it. I probably have to request access to it. Okay, let's try this. No, it won't let me go. Okay. Hmm. All right. Let's show the AI Studio just to have something up here. Can you continue? Okay. So Google Studio, Google Data Studio is dashboarding for everyone. So when you need a way to communicate your data and explain it out to anyone, you need clear, visually interactive charts, diagrams, graphs. Google Studio lets you do just that. It's a free visualization tool that connects to BigQuery, Cloud SQL, Google Sheets, Campaign Manager, Analytics, and more. And with this, you can build dashboards that have filters, selectors, time controls, and drill down views, all without writing a line of code. Whether you're presenting marketing metrics or machine learning model output, Data Studio turns data into decisions. Vertex looks like it's going to make enterprise-ready generative AI data. No, this is AI Studio. Nope. Hmm. I don't see it here. Well, bringing it all together, GCP's big data stack is ingested via PubSub or Dataflow. It's processed via Dataflow or Dataproc. It's stored in BigQuery, Cloud Storage, or Bigtable. It's explored with Data Lab or Data Prep. It's visualized in Data Studio. And behind it all is Google grade infrastructure, which is fast, secure, and global. Whether you're talking real time dashboards, training AI models, or exploring massive data sets across the globe, GCP offers tools to turn your data into insight and insight into action. All right. So, Google's global footprint. All right. Let's do this. Let's get you a visualization. Google Cloud's virtual global footprint is not only combined to, it's not just a few server racks in Silicon Valley. We'll get you a visualization here. Okay. It's a worldwide platform, over 17 regions, 52 zones, and 100 plus points of presence. GCP is built with global availability, performance, and redundancy in mind. Let's see. There you go. Each region, each region represents a geographic area, such as US Central 1 in Iowa, right? Or US West 1 in Belgium. Inside each region, there are multiple zones, isolated data center clusters labeled A, B, or C. For example, US Central A, US Central 1A, US Central 1B, and so on. Google requires at least 3 zones per region, ensuring that if one zone experiences a failure, your workloads can automatically fail over to the others without losing availability. For the exam, you should always design critical workloads for multiple zone deployment. And when needed, use multi-region application or replication for disaster recovery and geographic compliance. There's high availability built in. Here's the magic of Google's infrastructure. It's not just broad, it's also smartly connected and interconnected. Google's own private fiber optic network links its global regions together. This means low latency between services, even across continents, consistent performance for real-time applications, secure internal communication between your VMs, containers, and APIs. And all of this is abstracted away from you, so you don't have to configure the fiber routes. You just select the region, the zone, and let Google handle the rest, knowing the information we've already spoken about. So everything you create in the cloud, from virtual machines to APIs, buckets to billing, lives inside a project. This is your most important piece. Okay. What is a project? Huh? Why is this not working? Let's try this. Okay. So within this, you can select a new project, or you can select a project like you saw, or you can create a new project. Your project will have a unique project ID, a project number, and an option human readable name. Okay. And a billing account will be connected to this. Projects give you isolation, permission control, billing boundaries, and audit trails. These are important so that you can perform your tasks within your project effectively and be able to track it for any audit. So there's no need for peering or cross-account hacks. And just like regions and zones, projects are scalable and programmable. You can create a project through the console or through the CLI with a single command. Let's see this here. Okay. So here is an example of how you would do this. Oh, I already did create this. Oh, wow. There we go. So I need the G-Cloud projects, create. Oops. Okay. All right. So if we go over here, so created this project. Let's hit the reload. Maybe I didn't create it. I don't see it. That's okay though. We'll check back in a few minutes. Anyways, the new project is perfect for handling resources, CI/CD pipelines, or even spinning up temporary sandboxes for test environments. Projects are the atomic unit of billing, IAM policy assignment, and logging. Always manage access at the project level and shut down projects, not just resources, to stop charges. Remember, shutdown does not equal delete. A quick but vital footnote. If you delete a resource like a virtual machine or a Cloud SQL instance, that doesn't mean your billing stops. To fully stop a project from incurring charges, you must shut down the project from the Cloud Console or CLI. This revokes all billing, deactivates APIs, removes access for users, and archives the resource list. This is a common in exam and real-world mistake. Thinking a resource deletion stops all associated costs. It doesn't. GCP is project build. So what does this mean for you? Because resiliency, performance, and compliance begin with infrastructure, Google's global footprint matters. With GCP, you're not tied to a single data center or even a single country. You can deploy your app close to your users to reduce latency, keep regulated data in region to meet legal requirements, create failover architectures with confidence. And thanks to Google's internal technologies like Borg for scheduling and Spanner for distributed databases, you're getting decades of cloud reliability baked into every region and zone. So to recap, GCP is a global platform with 17 plus regions and 52 availability zones. Each region has multiple availability zones for fault tolerance. All your cloud work happens inside of projects. Projects are uniquely identified, auditable, and programmable, and billing only stops when you shut down the project. This infrastructure, the quiet foundation beneath your workloads, is one of the most powerful assets GCP has to offer. It's what turns cloud concepts into cloud confidence. So now we've gone over cloud service models, core building blocks, compute, storage, networking, analytics, and the global infrastructure behind it all. Now you understand the core offerings of Google Cloud, from compute to networking, storage to big data, and the global infrastructure that supports it all. Next up, chapter 2, we'll go into deeper detail into compute services. Till then, thank you, and we'll see you shortly.